Thank you for letting me introduce my intern project and experience in this tech talk. I have been working on the Yinyang K-Means clustering algorithm in HPCC Systems since last summer. So you may be wondering, what is clustering? Here is one example. So recently, LinkedIn have open public competition for mining their customer data. So how they can mine big data to find the potential elusive hubs between your professional worlds. Now here's one example. As you can see in the picture, clustering algorithms such as Yinyang K-Means can automatically categorize a customer's professional network into groups, such as previous employer, LinkedIn, college classmates from kind of kindergarten or industries you have been working in. So it can help us to see the way all your connections are related to each other. Even be able to identify the elusive hubs between our professional worlds. It looks pretty cool and also helpful for us to think about what we can do to extend our professional network for a better job or for a better future career. Another example is doing pricing segmentation. So for business users, Yinyang K-Means can help retailers to segment the customers based on customer spend patterns and understand the price sensitivity of the customers. Some of the segmentation variables considered such as total spend, value of discounts, percentage of discounts across transactions, number of items bought on discount. So based on all of this information, we can mining the data and find the discount variations of the customers. Another example is some organizations may think if they have a real loyal customer, so this can also be mining by clustering algorithms to finding the loyal customers. Some of the common expectations for a loyal customer, including frequent spend, higher ticket size, or diversified spend. So like Yinyang K-Means can help us, the retailers, understand customers by clustering them into different dimensions, such as customers who love the store, customers who just occasionally came here, or customers who just regularly come here for shopping. So this helps them to improve the business rate, also save the advertisement cost. So because of the power of clustering algorithms, we already have developed a lot of powerful algorithms in HPCC systems, such as K-Means, dividend trees, LDA. Oh, I'm sorry, pop up the view list. Yeah, so my intern project in the last summer is to implementing Yinyang K-Means into our machine learning library. And this summer, I'm working on improving the performance of Yinyang K-Means. So Yinyang K-Means is a job in replacement of the standard K-Means. It can achieve 2 times to an order of magnitude faster than standard K-Means. Also, Yinyang K-Means can guarantee the exact same result as a standard K-Means. That's why we're trying to implement Yinyang K-Means in our system. Because Yinyang K-Means is based on the standard K-Means, I will first briefly introduce the function how K-Means works in our system. So K-Means is an iterative algorithm. It first initializes the number of the clusters in the system. So here is the process how K-means works. First, we define the number of clusters we want to have in the data set, and then we randomly assign the centroids. And then we go into the looping function. The looping including two parts. One is assignment part, one is update step. So it's looping until the centroids don't drift anymore, or we can see the centroids don't move their position anymore. Then we can output the results, the clusters. Here is an example. It's more clear to understand the process. So we first choose the number K to be the cluster number in the data set. So here we choose 3 cluster centroids. I'm sorry. Yeah, I'm sorry. So in the initialization, we initialize the number of K, and then we assign a centroid ABC. And then in the assignment step, we calculate the distances between each data point to each centroid, and assign the closest one to be the closest centroid. So for example, we calculate the distances from Z1 to each centroid ABC, and then we find out centroid A is the closest one. So we assign Z1 to centroid A. And we do the same calculation for each centroid, B and C, and also all the points Z1 to Z9. So the result is we calculate all the distances from each point to each centroid. And based on the assignments, we now can recalculate the new distance of each centroid based on the update equation. The update equation is based on just the average, take the average of the distances of all the data belong to one centroid. So here is the equation. It's based on the relocate of the centroids. The centroids won't move or just within the certain drift. We can see the looping function has been converged. Then we output the results. If the looping function still not converged, that means the centroid is still drifting or moving. Then we still go back to assignment step, and then we looping from assignment step to update step until the looping function converged. So Yinyang K-Means improved the K-Means by reducing the calculation of all the distances. So Yinyang K-Means is first still same, define the number of K in the cluster in the data, and then instead of assign the K centroids, it first grouping the centroids into groups, and then based on the group information, it will go into the loop again, but this time the assignment step have 2 new components, the group filter and the local filter. They are the key components to help the Yinyang K-Means in assignment step to filter out the distance calculation. And then they go into the update step. The same as K-Means, it will looping through the update step and assignment step until the centroids don't drift anymore. and then output the number, the result of the clusters. So here is one example. We can see in the picture, Yinyang K-Means force the grouping of the centroids into groups, like in the circles. And they have data points C1, C2, and C3 at the beginning. And then we apply the group filter and local filter sequentially to filter out the unnecessary data point for calculation. More specifically, we have C1, C2, C3, and they first go through the group filter, and then the group filter first filter out the group of centroids. So then we can see after the group filter, we have only 3 groups left. I'm sorry. Please let me to turn back to the Yinyang K-Means. Yeah, so back to the topic, Yinyang K-Means using the diamond step and the group filter and local filter remove the unnecessary calculation of the distances between data point and centroids. And one example is we have C1, C2, and C3, and they both have, all of them have 3 groups of centroids. And after the group filter, there's only 1 group of centroids left for C1. And there's nothing left for C2. And there's only 2 groups of centroids left for C3. So that means for C2, there's nothing happened for C2 to calculate the distances anymore because group filter has already been filtered out all the centroids for it. So based on this, we can see Yinyang K-Means reduce the calculation dramatically using the group filter and local filter. So based on this understanding of Yinyang K-Means, I implemented Yinyang K-Means algorithm in last summer intern program. And after the implementation, this summer I'm working on optimizing the implementation. How to optimize the implementation? One step is to do the performance analysis in ECL Watch. So one example is in ECL Watch, there is a timer, times, and graph tab can help me to see which part of the code costs the most of time. So here, for example, the times tab in ECL Watch, we can sorting the timings. And then we see on top of it is the graph 2, subgraph 344 is the most time-consuming one. So you click Innate and go into Next tab to see the detail of subgraph 344. Then we go into the graph 2, ID 344 subtab. We can see in this list there is a lot of activity, but the most time-consuming one is activity 499, based on the time execution time. So we click on the sort. We go into the graph tab. So the graph analysis is very important in performance analysis because in graph tab we can see the whole data flow of the whole algorithm. Here we care about the sort function here in the middle of the data flow because it's the most time-consuming one. So we click on the sort, then we can see there is a property tab in the right side. It's called 499, and we can see which line is the code located in the ECL script. And here we can see it's located in line 196. But when we go back to check in the script, we found out it's not inside Yinyang K-Means function, but it's a helper function. So the way we're tracing back to the code inside Yinyang K-Means function is to go back to 2 layers. And we found out there is a read local data in the data flow. And we click on the read local data function. We see the code is sitting on the line 624. And then we go back to the ECL script in ECL IDE, and we found out, oh yeah, this code is sitting on line 624, and it's inside Yinyang K-Means function, and that is exact code called the helper function. So that's where we can go into to inspect why sorting function causes so much time. And then we transfer from the graph analysis to code analysis. So finally, we found out in ECL IDE line 624, the sorting function inside the dedupe costs the most time. And then I will optimize the code in mainly 3 ways. One of the optimization I can do is I optimize the sequential algorithm by recognizing the undistributable or insufficient component in the distributed manner. So some code may be working well when we program it in Java or sequential programming environment, but sometimes it's not that efficient or is indistributable in distributed environment. So we have to change the original algorithm to fit into our system. Another way is I add a global filter and combine with the group filter to avoid the nice-new communication between the nodes. And another way I did was to distribute the data set or record set smartly to avoid massive communication. And in the Intern program, after the implementation and optimization, I need to do code check-in or code review. In this process, I have my own GitHub account, and our company have official HPCC Systems GitHub account, so I will submit my code to the official account by submitting my pull request. And our system has management, our official GitHub account management by machine learning and ECL experts after they review my code, they will give my comments in GitHub and help me to improve my code. And at the end, I will submit my pull request to HPCC Systems. So in general, intern experience for me in the past two summer intern program is very awesome. I have very good experience, and I think it's mainly because I have a good communication opportunities with my mentor and my colleagues. We have instant message like Skype. We have just call each other. So I think the intern program have very good communication schemas here. And also we have lots of ways to asking for help. For example, we have HPCC Systems forum. Here is two examples of my posts. So I post my post on the forum, and I got really fast reply from the top ESL experts in our company, like Woman and Taylor. And they are really helpful, and I solve my problem very fast. And also you can just ask your mentor and colleagues, but sometimes they may be busy or they're not there. So online resources are very important. And also interning here, I feel like the work and life balance is very good. There's on-campus gym, and and also company will bring us to brief games. It's pretty cool. This is my general intern experience and my current project, and I want to use this opportunity to thank for my mentor Aiden, who always guided me and helped me, and also John Hall, who gave me tremendous help on my technical problems, and also Gavin and Jake and operation team always help me on my system problems. And also thanks to Lorraine and Ranu and also Trish organizing all the amazing events. And thank you for listening to my intern projects. And if you have questions, I can answer the questions.
All right, Lily, thank you so much. So I'll give you a second to look at the questions that have come in from our audience. We've got 3 of them there. But I want to thank you so much for doing this presentation, and I know that we certainly have enjoyed having you here. All right, I'm going to go ahead and start with the first question. So should Yinyang provide equivalent results to standard K-Means, or do you expect to be less accurate due to the optimization?
This is a very good question. I think for now, I'm still achieving the exact same result as standard K-Means because I want to balance from the accuracy and the speed up. So if we achieve a higher speed up, maybe we have to sacrifice a little bit accuracy. But for now, in our system, we still achieve the exact same result as standard K-Means.
All right, thank you. And here we've got a second question. What have been your greatest challenges when coding and optimizing this algorithm in ECL?
I think the biggest challenge for me is, last summer for me is the learning curve is from learning ECL in the last summer. For this summer, I think the challenging is how to really understand the algorithm and to make the sequential algorithm working well in our HPCC system. So I think for me in this summer is algorithm-wise problem make me feel more challenging than just coding in ECL.
Thank you so much, Lily.